Okay, so sig figs. These are the total number of digits recorded for a measurement or calculated quantity. And this applies definitely for calculations. Keep that in mind. All digits but the last are certain and known digits. Be careful to remember that there is always one. The last one is a guesstimate in many cases, or it's the one that wobbles if you're reading off of a device. So it's plus or minus 1 is assumed. Exact numbers do occur, however. These are things that have an infinite number of sig figs because they are counted values. So you don't have to say yes or no, is the last digit correct? No, it's just whether you count it or not. And so counted or defined values are going to be exact numbers, and these will be described as having an infinite number of significant figures. We'll get to some examples with those. All right, so doing this example with a ruler and some black rectangle. All right, so the rectangle lies on the ruler, and we can determine that the measurement of this rectangle, if that's truly centimeters, is somewhere between 1.7 and 1.8. Okay, and you could guesstimate that the length is maybe 1.74 centimeters. That's tolerable, but it shows you that these two digits are known, and this is an estimate. So the last one is your best guess given the equipment you're using. Now, here's another one. Let's try this. If we're looking at a graduated cylinder, how would we report the liquid in the cylinder to the correct number of significant digits? So you want all the ones you know plus the last one is guesstimated. Well, in this case, your gradations in the cylinder are magnified in this view on the right, and so this line that falls below the liquid line in there is certainly 17. So if you're reading correctly, this would be 16 and 17. Be careful to know which way is up and down. 17 is clearly not a correct number of sig figs because we know that it's more than 17. We know it's not 18. And is it going to be 17.6 or 18.4? Well, it's not 18. 18 is above that. So don't read your cylinder backwards or upside down, and recognize that 17.6 is a suitable answer. Whether that's 0.6 is your judgment call. So plus or minus 1 in that last digit is correct. All right, now, sig figs in measurements are important, and they're going to be something we have to practice to do them well. The main confusion lies in how you handle zeros in each of these cases, and where they lie helps you determine whether they're significant figures. So rule number 1 is about zeros in the middle of a number. Just like any other digits, they are always significant. So if you've got this value here, 4.803, all of those digits are significant. That's a 4 sig fig value. If you have zeros at the beginning of a number, they are what we call placeholders. They only tell us where the decimal place is. So these zeros over here are not significant digits, but they're important because they tell us where the decimal point is. One way of getting around confusion with sig figs is to convert to scientific notation. And so when you do that, you can see that the majority of those zeros have suddenly become unneeded. And so when you report it in scientific notation, we only include the significant digits. So 6.61 times 10 to the minus 3. Minus 3 again, remind yourself how that works because the 6 is in the 1 to 3rd place after the decimal. Pardon me, I'll fix that. Okay, so those 3 digits are only the digits to the right of the zeros that are counted as significant digits here. Next rule, zeros at the end of a number and after the decimal point, key there, are always significant. So if there is a decimal in your value, the zeros at the end do count. So that value shown, 55.220, all of the digits shown, all 5 are significant figures. Well, what else? The other possibility is there are zeros at the end of a number, and after a decimal point may or may not be significant. Let's move this thing here so we can see it better. And after a decimal point may or may not be significant. It depends what is shown here. If we don't have an explicit decimal point, then we are not sure. May or may not be. We do not know. And these things are ambiguous. And so the way we get around this is to report this value in scientific notation, it's going to be 3.42 times 10 to the, well, let's see, this is hundreds, 10,000s, 100, oh, yeah, thousands, 100,000, 10,000s, 10 to the fourth. But it could be 3.420 times 10 to the fourth, or it could be the one more digit of zeros in there could still be significant, but it's not reported in scientific notation, so we don't know that. So 4200 times 10 to the fourth. All of those are may be correct, but only one of those is correct, and that way you will know exactly how many significant digits there are in the reported value. All right. It depends on whether the decimal point is reported. Now, let's see. Let's look at some of these values and see if you can try them out. Test yourself. Pause the recording as needed to allow yourself to make a guess while you're looking through these examples. All right, first one, 24 milliliters. Think fast, think fast. How many sig figs? No zeros, no thinking. 2 sig figs. Next value, 3001. Zeros in the middle, trapped zeros, if you will, are always significant, so that makes a total of 4. Next value, 0.0320. Well, the zeros at the front are not significant, but the 0 at the end is significant because it is after a decimal point. So the 3, 2, and 0 are all significant. Next one, 6.4 times 10 to the fourth. No ambiguity. Scientific notation gets you around that completely. There's no extra zeros to think about. And so, in fact, it's just 2 sig figs. 560 kilograms. Ah, here's one of those funny ones where it doesn't have a decimal. We are not sure unless there is a decimal. So this one could be 2 sig figs. That's the only ones we know for sure, but it's ambiguous. Unless we put the decimal in there, it could be 3 if there were a decimal. All right. So the number of sig figs in the measured quantity is, pause while you think. Pause while you think. What are the number of sig figs in this quantity? Think, 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 think. And I hope you come up with the same answer I did. Should be 4, because the ones in the front do not count, and the rest of them are significant.